Machine translation is a subfield of computational linguistics that investigates the use of software to translate text or speech from one language to another. It has the potential to bridge language barriers and facilitate communication and understanding between people who speak different languages. This is particularly important in our increasingly globalized world, where interactions across linguistic boundaries are becoming more and more common. Machine translation is used in a variety of applications, including web page translation, document translation, and software localization. It can also be used to provide real-time translation services, such as those offered by Google Translate and Microsoft Translator. The goal of machine translation is to produce translations that are as accurate and fluent as those produced by human translators. However, machine translation is a complex task, and current systems still fall short of human-level accuracy and fluency, particularly when it comes to translating languages with very different structures. Despite these challenges, machine translation has made significant progress in recent years, and it is now a valuable tool for anyone who needs to communicate across language barriers. As research in the field continues, we can expect to see even more accurate and fluent machine translation systems in the future.
The idea of using machines to translate languages has been around for centuries. However, it was not until the development of the digital computer in the mid-20th century that machine translation became a realistic possibility. Early work on machine translation began in the 1950s with the development of rule-based systems. These systems relied on a set of handcrafted rules to translate text from one language to another. However, these systems were limited by the fact that it was very difficult to write rules that could account for all the complexities of human language. In the 1990s, statistical machine translation, or SMT, emerged as a new paradigm for machine translation. SMT systems are trained on large amounts of parallel text, which are texts that have been translated by humans. By analyzing these parallel texts, SMT systems can learn statistical relationships between words and phrases in different languages. These statistical relationships can then be used to translate new texts. SMT systems quickly surpassed rule-based systems in terms of accuracy and fluency. However, they still faced challenges in handling the nuances of human language, such as idioms, humor, and sarcasm.
Rule-based machine translation, or RBMT, is the oldest paradigm in machine translation. It is based on the idea that languages can be translated by applying a set of linguistic rules. These rules are typically handcrafted by linguists and cover aspects of grammar, syntax, and semantics. A key component of RBMT systems is the lexicon, which is a dictionary that contains information about words and their translations. The lexicon also includes information about the grammatical properties of words, such as their part of speech and their inflectional forms. Another important component of RBMT systems is the parser, which is a program that analyzes the grammatical structure of a sentence. The parser identifies the different parts of speech in a sentence and determines how they are related to each other. This information is then used by the translation engine to generate the target language sentence. RBMT systems can be very accurate when translating texts that are within their domain of expertise. However, they are often brittle and can produce ungrammatical or nonsensical output when faced with input that they have not been specifically designed to handle. Section 4. Statistical machine translation. Riding the data wave. Statistical machine translation, or SMT, is a paradigm that emerged in the 1990s and quickly became the dominant approach to machine translation. Unlike rule-based systems, which rely on handcrafted rules, SMT systems are trained on large amounts of parallel text. The basic idea behind SMT is that the translation of a sentence can be determined by looking at the probabilities of different possible translations. These probabilities are learned from the parallel text by analyzing the frequency with which different words and phrases are translated in different ways. SMT systems consist of several components, including a language model, a translation model, and a decoder. The language model is trained on a large corpus of text in the target language and is used to estimate the probability of a given sequence of words in the target language. The translation model is trained on the parallel text and is used to estimate the probability of a given sequence of words in the source language being translated into a given sequence of words in the target language. The decoder then uses the language model and the translation model to find the most probable translation of a given source language sentence. SMT systems have been shown to be very effective at translating a wide range of text types. However, they can still struggle with languages that have very different word orders and grammatical structures.